Okay, so 2.7, adding and subtracting rational expressions. So again, you got to remember how to add and subtract fractions. So I'll just scroll up here for rational expressions. When you go to add fractions, just remember if we have a simple problem like this, 2 over 5 plus 1 over 3. Well, how do you do that? Well, you have to first come up with a common denominator. So that's what I did there. I'll just redo it over here. 2 over 5 plus 1 over 3. You have to come up with a common denominator in order to add. You can't just add the bottoms and add the tops. That's not how you add fractions. You have to come up with a common denominator. The common denominator between a 5 and a 3, well, the easiest way to come up with a common denominator is just multiply the denominators together. That's not always the lowest common denominator, but it's definitely a common denominator. So you want to try to look for the lowest common denominator. Between a 5 and a 3, the common denominator is 15. So we can write both of these fractions as 15ths. And so how do we write them as 15ths? Remember, whenever you multiply the bottom of a fraction, you also have to do the exact same to the top. So in order to make the fifths 15ths, I have to multiply it by 3. So I have to do the same to the top. So 2 fifths is the same as 6 15ths. And in order to make thirds 15ths, I had to multiply the 3 by 5. So I have to do the same to the top. So a third is the same as 5 15ths. And then of course, in order to add these things together, what do? When you add 15ths with 15ths, you end up with 15ths. You add quarters with quarters, you get a total number of quarters. So you're adding 15ths together, the denominator stays as 15. You don't write it twice, it just stays as 15, and you add the tops together. 6 plus 5. Of course, we can add 6 plus 5. 6 plus 5 is just 11. So the answer to this is 11 15ths. So you got to be able to remember how to add fractions. And if you can add fractions, then you can definitely add fractions that involve trinomials. So it says, to add or subtract rational expressions, A, with a common denominator, write the numerator over the common denominator and add or subtract the numerators. Okay, so keep the denominator the same, subtract the numerators. With different denominators, you have to first find the common denominator, rewrite it, and then write the numerators over the common denominator and add or subtract the numerators. Step 2 is you have to state restrictions again. And then step 3 is divide by common factors. Okay? So you always first factor, then if you have to come up with a common denominator, come up with the common denominator, and then state restrictions and divide by common factors. Okay? So let's take a look at example 1. I have 7 over 4a cubed plus 5 over 6a. So I ask myself, can I add these things together right now? And the answer is obviously no, because this is over 4a cubed, but this is over 6a. So I have to come up with a common denominator between these two things. Now, again, the first thing I should be doing is factoring, but you cannot factor monomials, so that is what it is. So if you'd like to state restrictions right away, that'd be a good idea. The restriction on the bottom of this, 4a cubed, if that cannot equal 0, eventually a cannot equal 0. Okay? A cannot equal 0 because that'll make that bottom 0. Also, this one is the same restriction. A cannot equal 0. Okay? So you cannot have the bottom equaling 0 because that makes the problem impossible to do. It's undefined at a equals 0. So coming up with a common denominator, I have to ask myself, what's a common denominator between 4a cubed and 6a? Well, between the 4 and the 6, there's a common denominator. Now, some of you may say 24. Now, 24 is a common denominator, but it's too big. You want to try to come up with the lowest common denominator so that you don't have to cancel anything out later on, any common factors. So the lowest common denominator between a 4 and a 6 is actually 12. So I'm going to write a 12 here and a 12 here. That's between the numbers. And then between the a cubed and a to the power of 1, the lowest common denominator is actually not a to the power of 4, it's actually a to the power of 3. This one already is a to the power of 3, and I can make that one a to the power of 3. So that is the lowest common denominator between those two fractions. And then I got to ask myself, well, what did I do to the first fraction to make it 12a cubed? All you have to do is multiply it by 3. If I multiply this by 3, I get 12a cubed. So I just got to make sure I multiply the top by 3. So the top would be 3 times 7, which is 21. And then this one here, 5 over 6a. Again, what did I have to do to the 6a to make it 12a cubed? Well, I multiply the 6 by 2, and I multiply a to the power 1 by a squared. So essentially I had to do 6a times 2a squared to make it 12a cubed. So I have to do the same on the top. Multiply it by 2a squared. 5 times 2a squared is 10a squared. Now when you get to this step, please don't go canceling out common factors and all that. The whole point of this is so that we can add these two fractions together. So now we can start adding these fractions together. How do you add two fractions? Well, if they have the same denominator, you keep the denominator the same, and you add the tops. So the top is 21 plus 10a squared. And then, obviously, you can write this in the correct order. It's 10a squared plus 21 all over 12a cubed. This is your final answer. Don't go trying to cancel anything out because this is addition at the top and just a single thing on the bottom there. So this is your final answer. As long as you use the lowest common denominator, you will never have to cancel anything out at the very end. So let's take a look at simplifying one that's a little harder, a little trickier. Now it's not a trinomial just yet. They're not trinomials, they're just binomials. So it asks us to simplify this in state restrictions. Remember, the first step always is factor. Well, you can't factor this top. That top is x plus 2. You can't factor this top. It's x plus 5. You can't factor this. It's x plus 1. And this is x minus 4. So they are factored already. They're factors. We're trying to add these two things together. So after you factor, you state restrictions. Stating the restrictions, the denominators can never equal 0. So x plus 1, that cannot equal 0. That means x cannot equal negative 1. And x minus 4, that cannot equal 0. That just means x cannot equal positive 4. Those are my two restrictions. The tops can equal 0, so don't go adding those as cannot equal 0 for restrictions, because you'd be wrong there. You can have zeros as numerators, just you cannot divide by 0. That's where these things are undefined. And next year you'll find out, when you simplify these, they'll be undefined at these places, and your graph, depending on what it is, will have holes or something at those places, and that's when the fun starts. But anyways, now if I want to add these two things together, I have to come up with a common denominator, because the denominator here is x plus 1 in brackets, the denominator here is x minus 4 in brackets. So what is a common denominator between these two things? Well, a common denominator between those two things is, the easiest way to find one, is multiply the two things together. The common denominator is x plus 1 times x minus 4. That is the common denominator for both of these. X plus 1 times x minus 4. And then you ask yourself, how did I make this first fraction this bottom? Well, all I have to do is multiply by x minus 4. So I have to make sure I do the same to the top, multiply by x minus 4. So on the top, I'll have x minus 4 times 2 plus x, or sorry, x plus 2. And on the bottom, how did I make this one, for the second fraction, x minus 4, how did I make it this? Well, I just multiplied by x plus 1. So I have to do the same to the top, multiply by x plus 1. So this is going to be x plus 5 times x plus 1. Now, this is where a lot of kids go wrong. And the reason for it is not because they don't know how to do it, it's because of the lack of practice. So if I see you doing this on the test, I clearly know that you haven't done anything in the book, because in the back of the book you would have got all these problems wrong if you try to do it this way. Please do not go canceling common factors right now. Oh, I can cancel out x plus 1 and x plus 1. Oh, I can cancel out x minus 4 and x minus 4. Yeah, I guess you can do that, but you would just be undoing what you just did, which is come up with common denominators. You would just end up with the same thing that you've done, that you had to begin with, and that means you've done nothing. So, the proper thing to do now is add the fractions. How do you add these two things? Well, in order to add fractions with common denominators, you leave the denominator as is, x plus 1 times x minus 4, and you add the tops. So you write x minus 4 times x plus 2 plus that one, x plus 5 times x plus 1. And now we have to simplify it. We cannot leave this top like that. We actually have to expand this all out and add all this stuff together. The bottom stays as is, always. So if I multiply the tops out using FOIL or using expansion, everything in here times everything in here, x times x, so I'll just rewrite this as x plus 1 times x minus 4, and I have x times x is x squared. X times 2 is positive 2x. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. So that's the first binomial expansion. The second binomial expansion, sorry, I'm going to have to erase this right now. So I have a little bit of more room here. The second binomial expansion there. Keep the brackets there. Everything in here times everything in here. X times x, x squared. X times 1 is x. And then 5 times x is 5x. 5 times 1 is 5. So I end up with this. Then, clear the brackets out up top. This bottom stays as the factored version. Clear the brackets up top. Nothing's affecting that bracket, so I'll just leave it as x squared plus 2x minus 4x minus 8. And this positive sign affects everything in here. Not that it does anything, but if it was a negative sign, it would definitely mess everything up, so be careful there. That'll be plus x squared plus x plus 5x plus 5. So that looks like nothing's happened to that because it's just addition. Then your final answer will be x plus 1 times x minus 4 on the bottom, but at the top I'm going to add all of my like terms. So I'm going to add them by canceling them, crossing them out so I know what I've done. X squared plus x squared is going to be 2x squared. Then all my x's. 2x minus 4x is negative 2x, plus x is negative 1x, plus 5x is positive 4x. And then I have negative 8 plus 5, which is negative 3. So this is my final answer, 2x squared plus 4x minus 3.